Hello ladies and gentlemen, this is Mr. Santoro. Welcome to the screencast on piecewise functions. Piecewise function is a function where we have different equations for different intervals of the domain, and if you recall, the domain is the values of x on our graph. So the formula will change depending on the value for x. This is an important lesson. This is a bridge lesson between the functions unit and the limits unit. So we'll be looking at piecewise functions for 2 days, and we'll have a little quiz on them at the end. So let's take a look at the first function. The first one, we're asked to graph f of x is equal to x plus 2 if x is less than 2. Then we're asked to graph f of x is equal to 2x plus 1 if x is greater than or equal to 2. So if we continue the concept of graphing on the number line, when we have something like x is less than 2, that would be an open circle. And when x, for instance, here is greater than or equal to 2, that would be a closed circle. So if we need to graph this, we have to be able to know where to start our graph. So even though it's less than 2, I've included 2 here in my table of values because I need to know where my open circle goes to begin graphing the line. So x is 2, x is 1, -6, -10. Those are all values of less than 2. So when I put this into the equation, x is 2, 2 plus 2 is 4. When x is 1, y is 3, and so on. So I've color-coded that in red, and I've drawn the line of that graph in red. And if you see, I have an open circle here at 2, 4, because that is indicated by the function we were given, x is less than 2. Now if we go to the next part of the function, it's 2x plus 1 if x is greater than or equal to 2. So what I've done here are my values of x. I have values of 2, 3, and 4 for x. The corresponding y values are here. So I graphed those, and I drew that in blue the way I color-coded the chart. So if you notice, we have an open circle at 2, 4, and a closed circle at 2, 5, and that goes right along with the inequalities that we were given. So let's take a look at this. We have this graph. And is this graph a one-to-one function? Well, first of all, is it a function? The answer is yes, it's a function. It passes the vertical line test because even if I draw a vertical line right here, I have a closed circle and an open circle, and I'm only intersecting my graph one time. So it passes the vertical line test. It is a one-to-one function because it passes the horizontal line test as well. Now the next question I ask you, if you look down on your note sheet, is what is f of 0? So we look at our graph, and when x is 0, y is going to be 2, right here on the graph. The next question I ask you is what is f of 2? Well, when I go to x equals 2 and I travel up this graph, y is 5. Y is not 4 because we have an open circle at 4. I have a closed circle at 2, 5. So evaluating f of 2, the answer is 5. Again, rewind this if you need to, but I've color-coded this to try and make it a little more clear so you'll see what we're doing. Let's look at one more example. This one's a little more complex. F of x is 3x if x is less than or equal to 1, -1. F of x is x plus 1 if x is greater than -1, less than 3. And f of x is 2x if x is greater than or equal to 3. So I've color-coded this in a similar way. Now if you note, x is less than or equal to -1. So I have a -1 here in my x column, and I have a -3. When I put those into the equation, I have corresponding y values of -3 and -9. So if I scroll down here, and you'll see the way I graph this, x is -1, y is -3, x is -3, y is -9. And there's an arrow at the end because it will continue. The next part of the graph, if we look at this function, is if x is greater than -1 and less than 3, we're going to use the formula of x plus 1. So again, I need to include the -1 value and the +3 value, and I just put in a 0 in between, just have a third point to graph. So I put negative 1 in for x. Negative 1 plus 1 is 0. And I substitute the 0 and the 3 in also, and that's how I find the 3 y values. So I plot those. X is negative 1, y is 0, all the way to x is 3, y is 4. If you look at the function we were given, it's x plus 1 when x is greater than negative 1 and less than 3. And again, if we go back to what we learned about graphing on the number line, we'll see that they need to be open circles. So I have open circles on either end of the green line segment. Then I go to the last part of the function. It's f of x equals 2x if x is greater than or equal to 3. So again, I've got to start this 3 here. And I picked values of 3, 4, and 5. They gave me corresponding y values of 6, 8, and 10. Because my function is calling for x is greater than or equal to 3, I have a closed circle here at x equals 3. I've plotted the other points and I have the red line. So now our graph looks like this. The next question is this graph a function? The answer is yes, it is. It passes the vertical line test. Is it a one-to-one? It is that as well, because it passes the horizontal line test. Now let's evaluate for different values of x. If I ask you for evaluate f of negative 1, when x is negative 1, y is negative 3. There's a closed circle down there. We don't go to the open circle because that's not a solution. Our solution is only with closed circles. The value of x is 0 has been excluded from the domain for this part of the function. If we evaluate f of 3, when x is 3, I travel up, and there's an open circle there that's not included in the domain. I continue up to the red filled in circle, and x is 6. Then if I evaluate f of 5, I find out when x is 5, y is 10. So our graph will look quite different than the graphs we've been looking at. This is a piecewise function. And that, ladies and gentlemen, ends the screencast for piecewise functions. Please make sure that you complete the notes pages. And we'll be working on piecewise functions Monday and Tuesday. Thank you.